So with regular distillation, like with this distillation of salt, salt water, sorry, what we did is we heated up the salt water so as the water boils and goes up this tube, and then it leaves behind the salt. Then the water condenses back into, well, the steam condenses back into liquid water, and then dribbles down here. Now, this condenser is not actually not necessary because, but it does help. So, because the steam, now it's not near the heat, will condense anyway back into liquid water. But what the condenser does is allows it to cool down even more quickly, and so this we're not going to have steam coming out of here and then just drifting off into the atmosphere, into the environment. So the condenser is like a little sort of jacket around the tube, where water will go into just the jacket. Essentially, when I say jacket, it's a metal thing, but it's like a metal. I don't know how to say it. It's like a air conditioning unit, I suppose. It's just it's like a tube that goes around the tube. So the water from a tap will just go around it and then come out over there. So it just cools it all down, and then allows the condensation to happen more easily. So, and then you get pure water. So I don't need to worry too much about how hot I make it, because there's no chance I'm going to melt or boil the salt. I do have to be careful not to bubble it too much and let granules of salt go up here and then roll down here, because then it won't get pure water. But I'm not going to boil the salt, so that temperature doesn't matter too much. Over here, this is ethanol and water. Now I've labelled the right-hand side. We're going to just ethanol and water, but that was imagining we did it wrong. So this was if I heated it up and I didn't look at the temperature too carefully, and I would just boil them both off, and then they did both go over here. So if I move this now to that bit there, and we can say, so we start off with ethanol and water, and then what we do is we heat it up gradually until we get some. If we know what it is that we're trying to separate, then we just heat it up to the boiling point of ethanol and not the boiling point of water. Then ethanol would boil up here, and then it would start to condense down here, and we'd be able to collect it and we'd get pure ethanol. So this is essentially what fractional distillation is about. It's all about heating it up until you start. There is a little bit of boiling, and something within the mixture is boiling, and then don't go any higher than that temperature. Do the lowest temperature, which is leading to any sort of product, any sort of anything being collected here. Once we have something coming up here and then being condensed down there, don't go any hotter than that. Don't increase the temperature, and then you just keep going until you're no longer collecting any of that. Then you take this beaker and you put it to one side, and that would be essentially your first fraction. Okay, so fraction 1. And of course, this would, if you had a substance you didn't know what was in it, then you could separate it this way into do several different fractions. Then you could try to separate. These fractions are not necessarily pure substances, because it could be that this fraction 1 could be a mixture of substances with very similar boiling points. They would have all been boiled off at the same time. But you keep going until there's nothing more coming down here, nothing more dripping down here, and then we move it away and then put a new collecting beaker there, and then we increase the temperature gradually until the next fraction starts to be boiled off. Yeah. So that's what fractional distillation is with when in a lab. So it can be used to separate substances. It can also be used. The main purpose could be to identify what substances are in the mixture. If you suspect that water's in this mixture, then you can try to collect it and then see Is anything boiling at 100 degrees C? And if it is, then that's a good indication that the substance is water, for example. So it's not just, when you separate them, you're not just collecting the things that you need, you might also be trying to identify what's in the mixture in the first place. I'll just briefly talk about how it's different then in industry. In industry, the principle is still the same. You're still heating a mixture of liquids, like crude oil. Crude oil is a mixture of liquids. And you're heating it at different temperatures, which causes them to then be boiled off and then condense at different points. The main difference being, I guess, is that in the lab, you're heating up to the lowest temperature, which will cause one of the fractions to evaporate. Whereas in this case, what you're actually doing is heating it a whole lot up to really, really high temperature. So it all boils apart from the very lowest one, which is like lubricating oil, paraffin wax, or asphalt. These are examples of substances that don't boil. And because everything else is boiling and going upwards as a gas, and the rest of it can just be collected down this tube. So notice also this graph, this picture, can catch a lot of people out because it's actually hottest at the bottom and coldest at the top, and we often think it's the other way around. So the heat is at the bottom, and it gets colder as you go up. Not still pretty hot, obviously, but yeah. And at the very top, you've got just at the bottom, you've got things that don't evaporate at the temperatures we're heating it up at. You've also got stuff at the top which doesn't condense. So you're going to boil it all the way off, and then as it goes up, some fractions of this mixture are going to get cool enough to then condense. So fuel oil will condense at this height because it's at 370 degrees C. Fuel oil is going to condense, and when it condenses, if we zoom in on this, notice we've got these little hats on top of the tube. So when it dribbles down, when it sort of rains down, essentially, it turns from a gas into a liquid, it doesn't go back down these tubes because these hats are on it. So instead it just goes over that, then gets collected along the level here, along the bottom, and then gets collected off this tube. Meanwhile, the rest of the stuff, which wasn't fuel oil, carries on rising until it's cool enough for diesel to be condensed off, and that does the same thing. Then it condenses, rains down here, literally rains down, because if you think about it, that's what rain is. It's just condensing water vapor raining down, and when it gets collected, it then it falls down here. It doesn't go down these tubes because of these little hats, and then it dribbles off and down here, and it keeps on going. And the ones at the top, they're the ones that don't condense at all. Doesn't matter how cold it gets. It goes all the way to 20 degrees C, and it's still not condensing. So it gets collected off at this pipe here at the top, and that's butane and propane. So those are the main differences. So I'll just stop the video